Hey there. Recently, I purchased a bunch of these HP branded battery packs. They're about 20 bucks each, and they contain 24 LG HB2 1500 milliamp hour cells rated at 30 amp discharge. The cells that I recovered were of pretty good quality. However, I haven't really seen any videos about these packs in particular, and just thought I would make one. I originally purchased 8 packs, date coded mostly in 2019. There were 2 from 2013, which I believe is where I ended up getting some of the less performant cells out of. However, the majority of the cells that I did recover from these batteries were 1400 milliamp hour or more, which was great. I got 111 of those out of the total 192 batteries possible. These are all 1400 milliamp hour with the in that range, with the top one probably being about 1450 milliamp hour. The other cells that I recovered were a handful of cells in the range of 1200 to 1399, and about 30 cells that were 1100 to 1199, in the 1100 range. The number of 1100-ish cells that I got corresponds to the 2 packs that were from 2013, so I believe that's where these came from. However, I didn't actually pay attention to any of that when I was taking them apart originally, so I can't really confirm or deny that. That being said, I do think that these are a pretty good deal. For less than $1 per cell, you're getting good cells for an e-bike, for probably a Powerwall or whatever you're doing, or just to, have sitting around on your desk, like me. I don't know what I plan to do with these. Probably a battery pack would make sense, but I don't know for what. So right now I'm just kind of stockpiling. What I wanted to do today was disassemble one of these, show what to expect once you get inside, get the batteries out of it, broken down to a cell level, talk about some of the problems or caveats with these packs, and then show you what I end up getting out of the 4 additional packs that I purchased. So let's go. Okay, so here is one of the packs. It is long and small. It has, on this end, a little connector. You have all the power connections and the little BMS, I suppose, or data connection there. On the other end, you have a little lever. When you pull the lever down, this LED blinks. And the number of times it blinks depends on the state of the battery, which is marked here. You can see this is a pack from 2019. In fact, all 4 of the packs that I ordered this time are from 2019. So that bodes well for the quality of these cells, probably. So they come with tape on this end. You're going to want to pull that off just because you need to break the case along the seam, and the tape sort of holds it together. The easiest way to get it off is to just use a knife. Just kind of lightly break that tape seam, and that's good enough. On the bottom, there is a row of little Phillips screws. So you're going to take those out. These are screwed directly into the cell holders themselves. So you're not getting it out without this. Okay. I recommend keeping your workspace clean because you don't want little metal bits hanging around when you are messing with these cells. So keep your workspace clean. I'm pretty bad at that, so you're going to just have to take my word for it. So anyways, now that we have the screws out of the bottom, we can actually get to opening the pack itself. These little clips here in the plastic, there's a couple of little holes. Instead of trying to pry those open and potentially jam a screwdriver in there and short something, I like to just sort of clip these with my flush cutters. And then I like to cut the corners here because it gives you sort of an open area to start prying at. So see, as soon as I cut that, it starts sort of pulling up. You are pretty free to kind of pry in this area The cells actually don't start until maybe, I don't know, here or so. On this side you have maybe ½ inch, so just be careful. I use a little plastic trim tool from a set for, taking trim out of cars. I take this without stabbing yourself with the plastic thing. Just try to wiggle it into the pack, hopefully breaking the pack more than you break these shitty plastic tools. And then once you're into the edge, you can just sort of work it down the side like that. All right, good enough. Now most of the clips that are holding the lid on are off. You should be able to just sort of pry this up, just like that. Not a lot of glue in there. Not a lot of glue on the cells themselves either. There is, a little bit, there is glue, obviously. Most of it's kind of on the cell holders, but the cells are generally in pretty good condition. The 2013 ones, the wrapper is a little bit more brittle, so you'll probably end up having to rewrap some of those. But for the 2019 ones, the wrappers seem to still be pretty pliable, and the cells come out relatively clean. So from here, you can take out the little lever, and then there's the little LED/switch module down in there. You could probably use that for something. As far as I can tell, it literally just has the switch and the LED on it. The switch is a very tiny micro switch, could come in handy. BMS on this side with your 70 amp fuse. This is reusable. And then the BMS continues down this edge of the pack, if you can see it down there, where the sense wires and the temperature probes all connect into. So from here, there's 4 screws holding this board into the case, so let's get those out. Okay, so those are out. At this point, it's actually pretty easy to get these cells out of here. You can disconnect it from the BMS board here beforehand if you desire. I like to take it all out as one solid piece so I don't have to worry about everything flopping around and potentially shorting something on accident. So starting on this end, just pry out and pull the board up so the pack will sort of start falling out. Then I flip it over and just kind of keep doing that. Just lever the pack out and it'll fall out until it gets down to this end here where the LED board is, because there's a bunch of glue holding that LED board in. So I take the plastic and just sort of shove it down in there to try to separate it. Generally works pretty well. Something, keep workspace clean. At this point, you are in, but you're still tethered to the case. I wouldn't go just cutting this off because even though it's just for that little LED board, you might still end up shorting these leads together if you just clip that off. Haven't tried it, I wouldn't try it. So the easiest and firstest thing that you can do is actually remove this little connector that has the sense cables for each section in the pack, as well as this, and then you can just throw that away. It's got a little bit of elastic holding it on. You can just peel it off with your finger and then just pry up the connector. Easy peasy. So now that this is completely connected, you can just clip this. And that's disconnected. That board is down here. You can rip it out if you want. No, that's half of it. Just a tiny little micro switch on there. Could be useful for something if you wanted to try to desolder it, but really not a lot going on down here. Plus an LED, but this, to me, is trash. Let's take off this BMS board and get it completely separated from the battery. There's just the 3 screws holding it on. I plan on using this for whatever I make with these as well, as long as it doesn't need more than 70 amps. Great. Now it's mostly separated. It's just being held on by these temperature probe wires. You can just pull these out of here with reckless abandon. This board, don't know if it's reusable. It's probably proprietary. I might spend some time on one of these packs to see if maybe I can get in to here and control it or see the status or anything like that. I don't have a lot of hopes for that, however. Plus, this connector doesn't look like the most convenient thing in the world to use. It would be nice if you could just plug these in as is to like a Powerwall or an e-bike or something like that, but it's probably not worth it. This is probably good just for these lug connectors if you wanted to reuse those for your project or whatever, or just throw it in the recycling bin. Past here, it's just a lot of little cleanup. I like to take all this tape off, or mostly all of the tape off, because I want to clip this sense lead off of here as close to these terminals as possible so that they're not flapping around and they're not getting in the way when I'm disassembling the pack further. All right, so that's all that. More trash for the trash pile. And we'll just kind of lightly clean up here onto the floor. Okay, let's clip these leads off. So be careful when you're doing this, because shorting these two terminals is effectively going to short the whole battery, more or less, minus these cells. So like as you're going down, the voltage potential is lower, but you still don't want to short it. I probably don't have to explain this, but fire is bad, at least when it sets your house on fire. So avoid it. At this point, you could just stop here. You have a nice 12S 2P battery pack. It's got terminals on the end here. It's got places for you to attach your BMS leads. And all you really need to do is just maybe stiffen it up a little bit, put some Kapton tape over this, and then you're done. However, that's not what I want. I want to make a cell that has more in series, and I just enjoy breaking it down to the cell level anyways. Ow. God damn it. Originally what I had done when deconstructing these packs is take your flush cutters and just wedge under one of these terminals and just flip it off. I would maybe like medium force here, close your eyes, safety squints and all that, because this will pop off of here at approximately the speed of light. However, that's not the only option you have. These are soldered together, these packs of cells. So you could take a soldering iron to this connection and actually get these individual packs out of here, which could be handy. Again, I don't want that. I want the cells by themselves. I'm not going to do the desoldering just because I don't want to put heat into these cells, and my soldering iron is kind of fucked right now, and I'm lazy. So I'm just going to go with the flush cutter technique. First thing I like to do is take this end of the battery off, because this is what's joining the top two rows and the bottom two rows, and what makes things a little precarious, because any of these terminals shorted together are going to make big sparks. So first things first, we'll disarm the bomb by taking this sub pack off. Being cognizant of your clearances here between the terminals, just kind of getting in there like that and giving like medium light pressure and just wiggling it back and forth a little bit. Sometimes it'll pop completely off and sometimes just one side will break. That just broke one side, and we'll just kind of wiggle that the rest of the way off of there. I should definitely probably have goggles on, but I don't. So this is off of there now, which is great because the danger side is gone. And this pack suddenly becomes a lot safer to work with. Any of these terminals now shorted together, there's no voltage potential between them because this is essentially two separate packs and you would just be connecting one wire, so there's no a way for the bad stuff to happen. From here, I usually take the other end off because it's got these terminals flying about, and you'll just break all of those off. So let's do it. So those are all off. And what you end up with are, again, a stopping point. You could stop here and get a nice 4-pack of cells. This is actually advertised on Battery Hookup. This is how they recommend breaking them down, because you have basically 2P packs here, which is easy to use. You got your leads already. If you didn't, if you went with the soldering route and didn't break these little tabs off, you would have somewhere to solder to and everything. I'm not going to do this. I want the cells. Okay, so now you have all these packs. We'll save the end one for last. From here, I would say it's fairly standard. There's nothing really specific, I would say, to talk about when it comes to disassembling these. If you've disassembled tab welded batteries before, you will more or less know how to get the rest of this apart. That being said, there is a recurring problem that I've found with these, and possibly with other batteries too, but these specifically are welded very well with pretty thick nickel, like, I don't know, thicker than nickel that I have on hand at least. So you have a very good chance of popping a hole in the bottom of these cells, which renders them basically trash. I expect to lose at least 2 cells per pack, which still brings it to $1 per cell about, which I think is acceptable. You can probably get all 24 out if you're very meticulous and work slowly, but that is not what I do. I am relatively meticulous and tend to just kind of go for the least effort. So things to keep in mind, it's just when you're working on the negative side of this, be careful with how much you're pulling up, because you are going to be pulling pretty hard on the cell itself and you might pop a hole in it. So I'm going to disassemble the rest of this pack down to the cells and see if I can get all 24 out of this or not. Because once there's a hole in it, there's really not a lot you can do to save the cell at that point. I've seen reports that I've seen a YouTube video where somebody has been soldering the hole back together, and that doesn't seem safe. These cells cost me less than $1, and my house is worth considerably more than $1, so I will generally just throw those away. Well, and by throw them away, I mean put them back into the recycling bin. Okay, just pop that one open. You might have caught the little hiss. There, you can sort of see it, if I get my hand out of the way. A little hole right there. So, this is trash now. You can tell when this happens because sometimes smell the electrolyte. It's got a smell to it, you'll know. But most of the time I've noticed that these will, I guess either there's a slight vacuum inside, different air pressure in any case, and you can hear a little hiss, and that's the hiss of death. So at this point, I get out my electrical tape, and just for good measure, I seal that back up. And just for extra good measure, I put tape on both ends, and this goes in the to be recycled pile. And we continue. I'm gonna do the rest of these. I'm probably not gonna talk a lot. So here I go. All right, first cell's out. These are the cell holders. They are pretty flimsy. Not really something I'm gonna keep. You could reuse these, I suppose, if you wanted to. They have a handy little screw terminal. Not sure what thread that is, probably metric of some variety. I just throw them away. They're not really useful to me. And there you have it. Proof that you can actually get all 24 cells out of a pack with just a little bit of patience. So these are out. I'm going to clean them up a little bit more, though they're all in fairly good shape. The glue tends to break the wrapper a little bit, but that's an easy fix. So I'll test these. I'll test the other 3 packs that I have, and we'll see how good they are. Okay, so got them all done. Surprisingly, didn't put a hole in any of those 3 packs. Definitely not the norm. However, also surprisingly, I actually did get a pack that apparently had over discharged cells. These are all 1 point something volts, so we'll see how those recover.
3 days later.
So here's the results. Split them into 3 groups like I did for the first set of packs. Here we have under 1400, with the lowest being 1354. I got 22 under 1400 milliamp hour. I got 53 in the range of 1400 to like 1449. And then these all were over 1450, which is pretty good. The best one being 1485. And that's the best that I've seen out of any of these packs. And this is considerably more over 1450 milliamp hour cells than I got in all 8 of the previous packs. So I'm pretty happy about this. Of the low ones, most of them actually were 1380 or greater, which is pretty great. 1378, and then from here, 1383 and up. So most of these could probably be squeaked into a battery pack with the 1400s or thereabout, which is nice. No 1100s or 1200s this time out of all 4 packs, including the over discharge cells, which actually did pretty good. The over discharge cells were mostly in the 1400s, with some of them even being the highest rated of the bunch, like 1461 here. So those seem to recover just fine. They weren't over discharged way too much. It was only like 1.4 the lowest and 1.7 for most of them. So they did pretty good. Still think this is a great deal for these HB2s. Battery Hookup is actually sold out of these now, so hopefully they come back now that I've made a video about them. I would like some more, so I'm hoping they come back. In any case, keep an eye on Battery Hookup and keep an eye elsewhere. Who knows, you might find some on eBay. If you do, I think it's a solid buy, especially for 20 bucks.